Do you think you can understand an entire country's opinion by just asking 1,000 people? That might sound surprisingly small, but many major polls have only used 1 to 2,000 respondents before. How can that be enough to represent millions or even billions? The biggest challenge pollsters face isn't actually the number of people they ask. There's something sneakier, and it has thrown off polls with even millions of respondents. By the end of this video, you'll learn exactly what that problem is, how many people a survey actually needs, and how pollsters work to solve it. The goal of a poll? Ask as few people as possible to give us a confident answer. This is because asking everyone is impractical, and the more people we ask, the more expensive it becomes. So we need to use a smaller sample of the population. The question is, how much of the sample do we need to properly represent the entire population? For simplicity, we'll talk about polls with just a yes or no answer to find a sample proportion. The number of yeses divided by the total number of responses. Think of this like flipping a coin. Instead of a yes or no, it's a head or tails. The first 5 flips we might get all heads by pure luck, just like getting 5 yeses. If we were to flip the coin 1,000 times though, it is next to impossible to get all heads. Even getting above 700 heads would be extremely rare. As we flipped, each result balances our proportion out, and a result would tend to get closer and closer to that 50% for a fair coin. Polling's the same way actually. Asking more people is like flipping more coins. We inch towards the actual value. It just might not be 50% in this case. So if increasing our sample size leads to getting a more accurate answer, should we just ask everyone we can? Well, unlike a coin, we can't just flip people randomly, and how we choose people matters enormously. Let's say we want to find out what percent of the population plays video games. It's obviously not 100%, but if you only asked people at a video game convention, you would get an answer close to 100%, regardless of if you asked 10 or 1,000. This is an extreme example, but this is where that sneaky culprit comes in, sampling bias. And this has happened in real life as well. In 1936, Literary Digest polled that Alfred Landon would win the presidential race, and even asked millions of people. But it turns out, of the 2.4 million people who responded, they were their readers and people who own telephones and cars. And at the time, this meant that their sample was heavily biased to those with a higher income, who were more likely to vote for Alfred Landon, and was not representative of the total population. On the other hand, a competing pollster had managed to predict the right winner, only asking 50,000 people, a fraction of the other. So how do you avoid something like this? What happens if the people who responded to your poll just happen to all be similar, like what happened to Literary Digest? Well, statisticians try to address this by utilizing methods to carefully select people so that everyone has a fair chance of being included. This involves decisions on how people access the survey, the wording of the questions, and any incentives offered. So, after doing all that, what happens if 60% of the respondents just happen to be between the ages of 20 to 30? Wouldn't we have a massive imbalance towards those people who are likely to choose different answers compared to someone in their 60s? This is where an extremely powerful concept of weighting comes in. If younger adults really did make up 60% of the sample, but only 30% of the real total population, then the responses would be weighted down so they don't skew the results. It's the same thing if an unrepresented group only had a few responses, then they were weighted upward so the voices aren't drowned out. This helps ensure even if the sample happens to contain a strong percentage of one demographic, the results aren't skewed towards them. This helps ensure that even if the sample happens to contain a strong percentage of one demographic, the results aren't skewed toward them, exactly like Literary Digest. Together, weighting and random sampling are two extremely useful tools pollsters use to get an accurate picture of the population. So, does sample size not matter at all? Well, it definitely still does, but not in the way most people would expect. We want enough people to respond that we are still confident in our results. 10 people, even if representative, is simply not enough to be confident. There's actually a handy formula that will tell us how many people we need. If we wanted to be 95% confident in our answer, with a margin of error of just 3%, assuming a 50-50 split, we can plug this into our formula and get 1,067. This is the number of people we need in order to run a national poll. This is why almost every major poll targets at least around 1,000 people. It isn't arbitrary, it's grounded in statistics. Behind the scenes, statisticians also perform a couple of checks to confirm a bell-shaped curve applies to our data. When it does, this curve allows us to measure our uncertainty. And this finally brings us to where the margin of error and confidence level come in. Most polls you will see have these reported with them, but what are they? It essentially states how confident they are in their number. Imagine we found that 80% of viewers enjoyed watching statistics and are likely to subscribe. Speaking of that, subscribe if you aren't. We then find a sampling margin of error of 3% and a confidence level of 95%. This means we estimate the true value sits between 77 to 83%. And the 95% confidence means if this poll was repeated many more times, let's say 1,000, the intervals would change slightly each time, but 95% of the intervals would contain the true population's opinion. If that happened to be 81%, 95% of those intervals would contain the number 81. You can see this on screen with the stacked intervals. This is how we can estimate a population's value from a relatively small sample. Because of the sample size and careful choosing of individuals, bias can be minimized and a statistical confidence level can be chosen. Please note that this is also a simplified introduction. Real polling goes even deeper and involves additional layers like questionnaire design, response rate correction, and more sophisticated weighting models. No method is perfect either, and even well-designed polls can be inaccurate. This is why understanding the foundations helps you see them more critically. So, next time you see a poll, you know some things to look out for and why, when done carefully, a small number of people can still paint a surprisingly accurate picture.